Okay, what up guys? Welcome back to Herbs class, man, for 5 more minutes of math. So we've been talking about solving systems of equations for a couple of videos now. Now we've already talked about solving equations by graphing. Yeah, of course, where we would graph the two lines and find out what their intersection point is. And that intersection point will be the solution to our system of equations. Yeah, we also talked about solving the system by substitution. Yeah, and remember that was using an algebraic strategy where we would take one equation and plug it into the other one, creating one equation in one variable that we could solve. Now remember, that was best used when one equation was solved for a variable, right? When there was a variable that was by itself, we could take whatever that variable was equal to and plug it into or substitute it into the other one. Yeah, so, and also remember, if we were to graph those equations, the intersection point would be that solution to the system. Yeah, of course. Now today we're going to talk about the last way to solve a system of equations. Yeah, elimination. And let's talk about what elimination is. Yes, so elimination is the process of combining those two equations that we have in a system by vertical addition to eliminate a variable. Drop it out, cancel it out. I'll show you exactly what I mean with an example, of course. Okay, good. That looks like a good one to me. All right, so now here's my system of equations. I got two equations. They're both equations of lines. Now, if I were to graph these two lines, they would intersect at a point. Yeah, and that point would be the solution to my system. But maybe I don't have any graph paper, or maybe I'm not very good at standard form of graphing these lines. So there's got to be another way. Of course, there's another way. It's called elimination. So elimination, like we said, the idea of combining these equations into one by vertical addition. Since I'm going to be combining these and adding them together, just give me a total line. Yes, exactly right. So what I'm going to do is I'm going to combine these vertically. I'm going to put these x's with these x's, these y's with these y's, and this number with this number, hoping that one of my variables will eliminate. Let me show you what I mean. 4x minus 4x. If I combine those together, what would I have? 0. That's exactly right. So that would be the variable that gets eliminated. I'm not going to write a 0 here, so let's just continue on now with the y's. 8y plus 2y equals 10y, exactly right. And 20 minus 30, good, negative 10. Look what we have now. Our x's have been eliminated. Now all I have to do is solve this equation for y. Good, y equals negative 1. Now don't forget what a solution to a system looks like. There's an x coordinate and a y coordinate. Now we just found the y. Do you remember what we have to do after we find one of the variables? Yes, after we solve for that remaining variable, we plug it back in. So I'm going to take that y equals negative 1 and I'm going to replace y with a negative 1. Exactly right. Now it doesn't matter which equation I plug it back into. I'm just going to plug it back into the first one to keep it simple. Just like this. Yes, just like that. I take that y value and plug it back into one of my equations, it doesn't matter, to figure out what my x value is. And we use some quick algebra to solve this one. Step number 1, 8 times negative 1 is negative 8. Step number 2, add 8 to both sides, 4x equals 28. And then finally divide both sides by 4, x equals 7. Yeah! Now let's talk about how we write the solution. Bang! Just like that. Yeah! The x value of my intersection point is 7. The y value of my intersection point is negative 1. If I were to graph those two lines that we started with, they would intersect at that point right there. Yeah, that's exactly right. Okay. Now this one was set up kind of easily for us. We didn't really have to do any work because it was already set up. Let me show you a different example.